Thank you, Dr. Good morning, everyone. It's a pleasure to be here. And I was thinking actually before I came into the discussion as to what should I talk about. Right? So I tried to draw a couple of points which I wanted to talk about. But as we were having a conversation outside the room with Dr. Goenka as to, and I would like to a little bit adapt to that input. And what I would start with actually is a little bit about Nokia. What kind of supply chain do we have, so you know the context I'm coming from. And then I would go. So then I would go a little bit about what's unique about electronic supply chain. Often there is, when you sit into certain discussions with the officials, like Dr. Goenka said that you want to suggest to the government viewpoint, there's always a thing that, we have done it in auto, why can't you do it in electronics? And I would straight away say that if you have a different viewpoint, that's absolutely welcome. What I'm going to say is my views, the way I see the world. And I'm sure in your own experience you might have a different view, but that's, as an electronics professional, I would try to make a few comments over that. Then, and being the technology guy, this is the perfect start. It's always the case. So if you have technology which is a little bit not compatible, that's perfect. And that's exactly a perfect introduction of electronics actually. So I wanted to put it, but this is the perfect introduction. Then I would, when we talk about nuances of electronic supply chain, there are 2 points which I'll spend time on. One is the technology disruption, and second is the evolving skill sets, which is needed. So a little bit about Nokia. So we are a 24 billion euro company. We are in pretty much every country wherever you would need a network, or you have had a network, or you have a network. So we are there. We have about 100,000 people. And the easiest way to define Nokia is we are 6 companies into one. I'm sure most of you know about it, but I'll still kind of clarify. We started, I think let's say this 6 company into one journey, we started in 2007, wherein we became Nokia Siemens Networks. That time the network business of Nokia and network business of Siemens was put together. And on the way we bought Motorola network business, then we bought Panasonic network business, and in 2016 we acquired Alcatel-Lucent. All 6 marquee names, in their own right, they have had their own successes. But the fact that there are 6 companies merging into one, what we call Nokia today. We of course are very well known for mobile phones, but that's not a business we are in the business of as we speak today. So yes, you buy Nokia mobile phones, but that's through a brand licensing and technology and patent licensing to a company called HMD. So yes, we do make money on every phone someone buys in the market, but that's the way phone business is done as of today. This part of the Nokia, what I'm going to talk to you about is more on the networks. How do we run this supply chain? So what do we have in the supply chain? We have 25 factories, and you would see a word we have mentioned, own and EMS. So that means we have our own factories, and actually you can count it on 3 fingers. We have 3 own factories, rest 22 are EMS factories. EMS, we are partnering with Big 4, which is Flextronics, Foxconn, Jabil, and Sanmina, all 4 of them, and there are a couple of small regional players. Electronics manufacturing services companies. There are about 1,100 plus products, obviously it keeps changing. We move about 2,450 CBMs per day, 140 countries at the last count, 10,000 plus sales orders from customers are being processed every day. We have a pretty large supplier base. In ideal world, we would like to have it smaller than what it is listed here, but that's as of last count, it was 25,000 plus suppliers. As I said, we have 24 billion business, so we have about 14 billion plus buying. And then we have 8 hubs. So the way we run our businesses, we have our own factories, which is 25. We get the lot of stuff which we buy, we put it together in our hubs. Those hubs are located in different countries, not necessarily always near to the factory, because they are located depending on where it is best to keep the material to serve to the customer. And then there are lots of drop-off points, which is about 220 of them in different countries. So that's the kind of business we are in, and that's the context from which I am looking. I wanted to start with this, and I kind of liked it. Supply chain is something which is in the background. If it goes well, it's okay, that's what exactly you're supposed to do. The moment something is not working, everyone feels it, right? And
I almost think of Trump saying something like this.
So he's making it tricky. He's actively making it tricky. Absolutely, but I would completely agree with you. When it doesn't work, everyone feels it, right? And you get the corporate announcements, you get profit warnings, and you get whatnot. And you know, the most recent ones is an announcement from Apple, right? I'm sure you read it. There'll be more to come because of the coronavirus. But it's tricky. It's something you may or may not appreciate when it's functioning well, but you definitely remember and you definitely miss it when it's not functioning well. But that's a good way to put across the supply chain. And now I go to my next point, which is an electronic supply chain. And I was thinking, what do I say? And I said, it's not business as usual. Most of us have our own definitions of how supply chain is and how electronics business is. And I say it's not normal. There is always something different which is happening or which has happened. And the first and most important topic here is technological disruption. And technology disruption is everywhere in electronics. Talk about the products, talk about the supply chain, talk about just about anything, whether skills, anything. There is a lot of disruption happening all the time. 2 points I would like to talk about, and when we were in the car this morning, Dilip and we were talking about, so he said he's going to talk about a shelf life of, product shelf life of, life cycle of about 20 years. And I was like, perfect. So I'm going to start on the other end of the spectrum. And in our case, we are lucky. We used to have, by the way, when we were in early 2000s, we used to have that kind of life cycles. So you design a base station, install it in the field, and it goes on and on and on. That's unfortunately not the world today. Our typical designs are not lasting more than 2, 3, 4 years. In 2 to 3 to 4 years at best. You have changed something very significantly, and whatever you had done earlier is not needed anymore. Or you have a new design which is ready to replace that old design. That's the first thing. Second thing, which is having an impact on the business, and I would talk here in technological disruption itself, because of this kind of disruptions, there is a significant erosion in the value of the inventory. And I remember one of my old bosses when I was like, let's say at least 15 years ago, one day he was saying, Satendra, make sure you take care of the inventory. I said, yeah, I'm taking care of it. And he said, always remember, this is not buying. It doesn't get better with time. It doesn't get more expensive. In electronics, it becomes very, very less valuable over time. And typically, depending on what industry you are in, or what part of electronics you are in, you're talking about anything from 5 to 25%. It could be even more. But that's the range which I picked up. So whatever you have would be 25% less, or could be 25% less 1 year later. Maybe even more. Or may not even be needed in some cases, depending on at what point in life cycle you are. So that's one of the technology problem. Second is generic, and I would save it for the next slide, which is about implementation of technology in electronics manufacturing itself. So I have a case which I will draw upon, which is from our own facility in Finland. So that facility was recognized as McKinsey WEF Lighthouse Factory last year. So I'll draw upon some of the things which we have done over there. But a lot can be done, a lot has been done, and technology adoption in electronics manufacturing means very different than other industries. Second thing is intellectual property, and there is always a discussion, okay guys, so when I sit across and we say, okay, we have done good manufacturing in India, etc., and immediately the question is coming, okay, so why can't you get your suppliers into India? You see, company A, B, C, and D has done, and they have the suppliers right next to them. And so with your permission, I would take liberty of saying it's automotive reference they always give. And that's the reason I tried to put this point here. In electronics, unfortunately, it is not so. Why? Because intellectual property largely is with the component suppliers. Where the components which make the difference, or which are changing the designs and changing the usage and use cases in the field, those components, the intellectual property is with the suppliers. Intellectual property here just doesn't mean the product intellectual property, it also means process intellectual property. So if you talk about complex integrated circuits, so some of the ICs which we are using without naming the supplier, we are working with top of the top suppliers in technology. But there was a delay in a semiconductor chip to be available to us, and that was something which we kind of, our CEO called out in one of the results announcements. So, as much as we had the design ready, we had everything ready, but the chip was not ready because there was something, without going into details. So that's another difference. Second thing is the scale. So I could tell somebody, okay, I need resistors, capacitors, and whatever else. But the point is, the scale is very different, and we're talking about tens of millions, if not hundreds of millions, pieces being produced every year. That's the scale in component manufacturing. Now, that's not the scale at which it gets consumed in industries other than consumer industry. So, if it's a mobile phone, yes, it gets consumed in that kind of scale. But even there are different technological requirements. So, you could have the component, and I've had the discussion wherein component is available in India, but you can't buy it because there is a different technology. So, that's the second. Third thing is fragmented and global. So in electronics, my way of thinking is, and I'm drawing upon my own experience from our facility in India, is supply chain is fragmented and global, and I would rather not worry about making everything local. I would say I would worry about few things which I would like to have local, and those are essentially the freight heavy parts. So if I can get my freight intensive parts locally, everything else I would be good. So that's my way of looking at a manufacturing like this. Fourth point is intelligence everywhere, which is there is a lot of data in electronics manufacturing which is already available, unlike many other manufacturing wherein data is still to be brought in. In our case, data is everywhere. Can you make use of that data? Can you have the intelligence in your systems? Depending on how effectively you use it, you will be in a position to make the supply chain work effectively, or have your business run effectively. Have the goods where it is needed before it is needed, as I would like to say. Fifth point is geopolitics and entry barriers, and why I chose to write here, despite the fact that this could be for everyone, right? Like Dr. Goenka was saying, Trump, absolutely, he's working hard. On a lighter side, he kept me very, very busy, or many of our team members very, very busy for a year and a half. Because we had to literally kind of try to guess what next. And my best memory from that 1.5 years is, in our case, we moved manufacturing. We were pretty well prepared, but I would say to the extent where we were not prepared, we moved some manufacturing closer to the market. There are two moves we made. One was closer to the market, second is closer to the supply. Closer to supply move in our case was Taiwan. That was one country we considered, and closer to market we considered Mexico. And June last year, suddenly one day he woke up and said, I'm going to have 25% on Mexico. I was like, what the heck? Because he had this USMCA already done, and in my mind, thankfully did not turn out to be as bad as I thought. But that's one of the things. In electronics, it becomes more sensitive because every country is talking about safety. So that's another problem. So from safety perspective, security perspective, people would like to ensure that electronics is safe, is secure, and you have heard enough articles about it. So many countries are asking to have manufacturing in their own background. And then about the skill sets. So let me kind of skip through this slide. I wouldn't spend time on this. Now it's too much of text. I would ask you to pay attention only to the left one. So this is a use case from our own facility in Finland, which has done significant work on Industry 4.0. 5 broad baskets here. We did virtualization of new product introduction, which means we can do a lot of virtual simulations even before we get the product over to the shop floor. Because we have many products coming in all the time, like I was talking about the life cycle is getting shorter and shorter. The only problem here is our products are not very simple products. The products which we are talking about have about 10 to 20, 30, in fact up to 40,000 components on one product. A typical mobile phone has anything between 300 to 1,000 components. We are talking about 40,000 components. Our India facility makes products which are about 16 to 17,000 components. So it's very complex, and hence this simulation comes in handy. The benefits, we were able to reduce the lead time by 50%. We were able to reduce the defects 30%. Then we use flexible robotics. I would not talk about it because I'm sure Dilip will cover a lot about this. I'll talk about the private LTE, and that's something which is, we are on the user as well as supplier side. We have about 120 different companies wherein we are working with them to provide them the private LTE. Essentially, it's about going wireless and secured wireless. Often we have been using wired connection in the facilities. Then we turned it over to Wi-Fi. Wi-Fi is not as secure. Essentially, it's about security, and that's where private LTE comes in. Digital twins, we use it in our own manufacturing network, so you are able to simulate how the supply chain will behave, how you are able to, sequence your products, and it's used across the manufacturing. We got about 25% productivity improvement and defect improvement by 50%, efficiency improvement by 20%. And 70% reduction in the tester failures. So many benefits, and of course the last one is connected AGVs and AIVs, so which is like standard stuff. The only difference is it's connected, so it's able to do things on its own than us telling it what to do every now and then. And I know I'm already running out of time, so I'll take last 1 or 2 minutes to talk about it. As much as we have many of these things which we are talking about in technology, in our industry, there are many things which have been happening: lean leadership, value stream, yes, IoT, good. When you do the IoT, you have a lot of information, a lot of data available. Trick is to convert the data into information and act on that information. And that's where a lot of work on data analytics, machine learning, artificial intelligence is happening. We do a lot of it because in our case, we never know exactly which way our customer's requirement will go. I think it's the same with many of us, but in our case it's a little bit more unique. So it's because our customers are large telcos, so we are into B2B business, but there is a significant impact of the consumer behavior on our business. The way consumers are behaving, the way they are consuming the data, higher amount of data, like typically, if I remember from last report I read, in India we are already at 10 GB a month. So that kind of data consumption is driving huge demand, and it's to a large extent it's becoming difficult to estimate what will be needed where. So we really need to analyze where and how the demand for our customers will go, which is driven by the consumers like all of us here inside and outside this room. So that's another thing which we are spending a lot of time with. So I would actually stop here, and there were a few things I wanted to share with you about our own facility, but we can take it in the interactive session. So with this, I would stop to ensure that we are on time.